Okay, so in the last class, we had been discussing about the solution of unit commitment problem using the dynamic programming method. Before that, we discussed another method for solving the unit commitment issue, and that was shown by an example. That was the priority list scheme. Okay. So if I start over from the problem again, so we have this description of the units where the fuel cost for each of the units is considered to be same for this example. So we have 4 units among which we have to decide about committing or decommitting. Then each of the units have its own maximum limit and the minimum limits. Incremental heat rate is given in British thermal unit per kilowatt hour. No load cost is also given, which means that even if the generator or the unit is not providing anything, any significant output, even then there will be some cost associated with it. Okay, so when you calculate the cost associated with a certain unit, then we have to take into account this no load cost as well as the cost which is associated with the production of the unit. Then we have the information of the full load average cost. In the last class, we mentioned the process and we also mentioned the formula for calculating this full load average cost. And then we have 2 more informations associated with the units. We have the minimum uptime and the minimum downtime. Then this slide showed us about the initial status of the units. So the minus sign means the unit is offline, and the corresponding associated numerical value gives us the information about how long the unit has been online or offline. So if it is a minus sign, that means the unit has been offline, whereas if it is a plus sign, that means it is online for that amount of hours. So here -5 means this unit number 1 has been offline for the last 5 hours, whereas for unit number 2 we have +8. It means that for the last 8 hours the unit 2 has been running or it is online. Then we have 2 costs. One is the hot start cost, another one is the cold start cost. We will show how they help us in calculating the unit commitment, different parameters or different values associated with unit commitment or the costs associated with the unit commitment problem. And we also need the information about the startup hours, which means that if, let's say, the unit 1 has been turned off for 4 hours at least, then we will assume that the unit has been cooled down completely. Similarly, if unit number 2 has been turned off or shut down for the last 5 hours, then it has been cooled down, and so on. Okay. So there's a difference, slight difference between the first 3 units and the last unit. So you can see clearly that for the last unit, we don't have any startup cost and we don't have any associated startup hours. So we can assume that it is a quick start unit, whereas the first 3 units, you can assume them to be larger units, okay, larger capacity, larger units or thermal units. So this was the load pattern. So the problem was given for unit commitment. It was for 8-hour duration. So starting from hour number 1, we have up to hour number 8, we have a variation in load. So the load value was assumed to be constant throughout an hour. So we can say the load value were sampled at each hour, okay, not in between, not every half an hour. Rather, for every hour, we have some load value. And in between that hour, for the next consecutive for the next hour, from this hour to the next hour, the load is assumed to be constant at that sampled value. Then we prepared a capacity ordering unit. So we said that before preparing the capacity ordering unit, it is better to prepare the binary combination. Okay, so you prepare the table, this table, according to the binary combination, and you calculate the maximum output for the combination, and then you rearrange the ordering, and you number the states according to the highest capacity up to the lowest capacity, okay, in the descending order. So accordingly, the combinations there will or may not follow strictly the binary ordering. Okay, so you have to shuffle these orderings in between. These orderings are to be shuffled so that this ascending or the descending order is maintained here, and then you will put the state numbers. So the state numbers are only attached to the table once you have completed this ordering. Okay, so in the binary table you don't need to assign any state numbers. Okay, so then we said we have 3 cases to be studied, and we said we will go one by one. So this was discussed in the last class. This was the simplified characteristics, unit cost characteristics, we should say. So in the x-axis we have the production. So we have the limits between P min and P max, and before the P min has reached, so you have some associated no load cost. Okay, so that means even if the P min has not reached this, there is some non-zero no load cost associated with the final cost calculation for the unit. Okay, so the formula that is used here is basically in the form of y equals mx plus c. Okay, straight line approximation. So then we started the calculation by with the calculation of the unit incremental cost IC. So I showed you how to convert the units. So whatever values is shown here at the end, these are nothing but to convert to help us in converting the given units in BTU per kilowatt hour and dollars per MBTU into our required units, which is in dollars per hour. So why are we calculating this here? Because we will need this information in calculating the cost here. So you can see here that we need the information of incremental cost here to find out the final cost of the unit, okay, or the production cost of the unit. So that's why we need to calculate the incremental cost. So this is done in this slide. So the incremental cost is calculated given the fuel cost and given the incremental heat rate. The formula is provided here. Then in the first case, we said that we are following the strict priority ordering. So as we are following the priority ordering, so we have to follow the priority strictly. So what was the priority? The priority was set according to the full load average cost. So this was the full load average cost. This was actually given in the actual problem statement. So we have arranged the units according to their full load average production cost in the ascending manner. So so the most prioritized unit, or the topmost priority unit with the topmost priority, is unit number 3 because it has the lowest full load average production cost, and accordingly the remaining units are listed. So we have a priority of 3, 2, 1, and 4. So if I choose the states according to this priority ordering, then first state that is to be chosen, of course, I have to turn on unit number 3 first. So that's why you see first you have to turn on unit number 3 here. Unit number 3 is turned on. So this state 5 is chosen as one of the allowable states. Then I have to turn on unit number 2. So it would be 0, 1, 1, 0 because 2 and 3 are turned on. So state number 12 is also included as the allowable state. Then I cannot choose 13, and I cannot choose actually between anything between 6 and 11 because they violate the priority ordering. That's why I can't choose them. Similarly, I can't choose anything between 1 and 4 if I am following the priority ordering. So the one which are satisfying the strict priority ordering are these 4: 5, 12, 14, and 15. So this is why they are included in the set of allowable states: 5, 12, 14, and 15. So that is how much we covered. We also discussed a little bit on this slide. So let's start from this slide today with the background provided about the last class. So this is case number 1. We start the calculation. So this is our number 1. So what was the demand in our number 1? We have to check back the demand profile. So probably the numerical value, exact value will be given to you. So you know that this is in between 400 and 500. So exact value is 450. Okay. So the demand is 450. So this is the load demand. And initial condition is taken L equals to 12. How you choose this state? So you can see that in the problem statement, it was mentioned that which of the units were, to start with, which of the units were online. So you can see unit number 2 and unit number 3. These two are the units which are having a plus sign here. So their initial status is on, and they have been on for the last 8 hours. So the status is basically 0, 1, 1, 0, which means in our capacity ordering table, if I go for the capacity ordering table or this same table here, so I'm basically here, okay, 0, 1, 1, and 0. So the initial status to start with is state number 12. So let's start with L12 and which are the feasible states. So I said there is a slight difference between feasible state and allowable states. Feasible states are those which can, those states which have the minimum capacity to satisfy the demand. So you can see now, if I go back to slide number 39, the state number 5 can maximum, it can produce 300 megawatts, but your demand is 450 megawatts. So this unit 5 can't satisfy the demand, so it will not be a part of the feasible states. So only feasible states for our number 1 will be state 12, 14, and 15, because they have sufficient capacity to satisfy the demand of 450 megawatt. So, so that's how we limit the feasible states to these 3 only. State number 5 is not included. So this limitation is due to capacity limitation of state number 5. So then we said, okay, so we were looking for the next step, okay, how we are going to progress our unit commitment solution using dynamic programming. So the next probable state is listed here, okay. These 3 here are the 3 elements taken from X. So you see 12, 14, and 15. So these I values, elements in I column, okay, elements under I column are taken from these feasible state set, elements of the feasible state. L is, okay, L is now, we have only one initial state, so we take L. Same for all the entries, we have 12. So that means our progress can be, okay, we can choose either to go from 12 to 12. Our next state could be 12, or our next state could be 14, or our next state could be 15. Which one to choose depends on the minimum cost. So now we will be going towards calculating, okay, progressing towards calculating the cost associated with this transition. This is known as a state transition. This means that we are initially at state number 12. So what would be the minimum cost associated with this load demand, okay? To satisfy this load demand, what will be the minimum cost? So should I go from state 12 to 15, or should I go from state 12 to 14, or should I stay at state 12? This information will be obtained after we complete the calculation and after we reach at the last column in this table, okay? So let's see how we do it. So the third column is the unit production, okay, here unit production. So we have 4 units, unit 1, 2, 3, and 4. These are listed. So let's start from the bottom, okay? So we have 12 to 12, okay? This is the transition. That means we want to stay at 12, which is one of the feasible states. So we can choose this. Now our demand is 450 megawatts. So how are we going to distribute the generation among the units? So in this example, what the technique that we are following is basically like this. So the first priority, the units with the first or topmost priority will be loaded first. And then we will look for other possible, other generations from the other units, okay? So the total load is 450. Now the first question comes, can I take the full generation from the first priority unit? I repeat the question. The first question is, can I take the full capacity out of the first priority unit, which is, for our example, unit number 3. That means, can I take 300 out of 300 from unit number 3? Remember, unit number 3 is the maximum capacity of Okay, so you see here in slide number 30, we have the unit description. So you see unit number 3, it has the maximum capacity of 300. So that means I can take 300 out of 300. Okay, I can take out 300 out of 300. So I will load unit number 3 to its fullest capacity. Then I will go for the next priority unit, which is unit number 2. Remember, state 12 says 2 and 3 are only turned on. So I can choose among these two only. So I will fill up whatever capacity unit 3 has. I will take the full capacity of 300. The remaining I will take from unit number 2. So how much remains from 450? It is 450 minus 300. So unit number 2 will give me 150, which is possible because you see its maximum capacity is 250. So I will take 150 out of it to satisfy the demand. So in slide 40, okay, so we are jumping between 30 and 40, these two slides. Okay, so you see it is 300 from unit number 3 and it is 150 from unit number 2. Okay, so this is how we satisfy the demand. Okay, how do you calculate then the P cost for this interval and this state? Okay, so we're looking for P cost at interval number 1. Remember, we are at hour number 1, so our K is equals to 1. So P cost, this would be 1 comma I. What is I? I is here 12. Okay, we are looking at this combination, this state transition from 12 to 12. So I is here 12. So what I'm looking for is this here, this calculation, P cost 1 comma 12. So how do you calculate it? Remember, we have some no load cost and we have some fuel cost associated with the increment. We have some incremental rate value. So if you go for the formula again, if I go for the formula in slide 37, you have this. So you have some no load cost plus some incremental cost multiplied by the output of the unit. Okay, so no load cost plus incremental cost multiplied by the output of the unit. So this is how we are going to calculate the P value there. So this 684.74, this is the no load cost for unit number 3. Okay, no load cost for unit number 3 plus incremental cost of unit number 3 is 17.46. Remember, these are already calculated. I'm just plugging in the values into that formula which I have just shown you. So no load cost of unit 3 plus 17.46 is the incremental cost of unit 3 into the production of the unit. So production of the unit from this table, we find it is 300. So this block, the first two blocks here belong to unit number 3. Then we have 150 output from unit number 2. So next we continue. This 585.62, this is the no load cost for unit number 2 plus incremental cost for unit number 2 multiplied by the production. The production is 150. You get it? So in total, we get 9208. So this is how I have just shown only one. The remaining are the same. Okay, is it okay? How are we getting 9208? Just plugging in the values.
Yes, sir.
Okay, so let's continue. Now, what about this column? What is S cost? S is, as I said earlier, S is the state transition cost. So you see, the transition will happen in this manner, in the bracket. So it is K minus 1, comma L to K, comma I. So what is K minus 1? K minus 1 is the basic or the current, or you can say the initial for this case. Okay, what was the state at initial hour? Okay, so initial hour, initial condition was 12. So you see, hour is 0 because we are considering this calculation for hour equals to 1. So K minus 1 will be 0 here. You see, you follow this column, K minus 1 will be 0, this entry. L is 12, so it is 0, 1, 1, 0. Okay, this is the state taken from the capacity ordering unit, the combination 0, 1, 1. You can also see it here 0, 1, 1, 0. These are the units on, and the dash having the off units. So I am trying to transit from this, go from this combination and this interval to the next hour. So the next hour is K. So for us, for this page, K is 1. So this is K1. And I, for this row, I is 12. So again, this is 0, 1, 1, 0. So basically, there is no transition. Okay, no states are, we are not transiting from one stage to another state. So the associated cost will be 0. When will it be non-zero? It will be clear in the next, this row and this row. Okay, so for this one we have non-zero state transition cost because we are staying at state 12. So we are not actually going to any other state from the previous initial state of 12. We are staying on the same state. That's why the associated S cost is 0 here. What is F cost? F cost is the minimum cost in the previous hour, because our problem statement, this is the first hour we are considering. Okay, so we have no data associated with the previous hour. Okay, we have no demand data associated with the previous hour. So this value for the first hour will remain 0. Okay, for the previous hour, F cost K minus 1. K minus 1 means 0th hour. So for 0th hour, we don't have any load demand. So we don't have any information here. So the associated minimum cost is basically, we will take it as 0. Okay, we'll fill this up with zeros. So what is total F cost Ki? F cost Ki is basically the summation of this value, and this value. So because these and these two are 0, so simply it will be 9208. This is the explanation of the last row here in this table. Now let's move to the second row. Okay, so in the second row we decide, okay, what will happen if I choose the different path, if I choose to move to different state from 12, if I choose to go for 14. So what is the combination in 14? Let's check. 14 says it is 1, 1, 1, 0. So unit 4 is still off. The first 3 units are on. So let's check. So you see the unit 4 is giving nothing, the dash means 0. So now we have to take into account of the contribution from unit number 1. Okay. So now the question is again, how are we going to fill up these 3 gaps? How are we going to fill up these 3 gaps? Okay. The answer is the first part remains same. Okay. We will first check the first or the topmost priority unit. Can I take the maximum capacity from this unit? Okay, the demand is again still the same. So yeah, I can take it. So I will take 300 for the first priority unit. Then I will go to the next priority unit. Okay, now the question is, can I take 150 out of this, the remaining demand? The answer is no. Why no? Because I have decided to turn on unit number 1, and there is some minimum generation that should be made available from that unit. Okay, there's some minimum generation. So I have to at least take 25. Okay, I have to at least take 25 for this case. The remaining will be taken from the middle unit. Okay, let's say if the minimum here was 0, let's say, okay, if the minimum were 0, in that case I could simply write 0 here and I could simply take 150 here. But there is some minimum requirement from unit number 3. Let's go to slide number 30. Sorry, minimum requirement, we need unit number 1. So you see there's some minimum 25. So if I decide to run unit number 1, then I have to at least take 25 out of it. I can't take anything less than that. So that's why I can't take remaining 150 from unit number 2. Okay, so I have to take the minimum from unit number 1, and then the remaining I will take from unit number 2. Any question here? Is that clear? Because the same rule will follow here and in the next consecutive slides. Why are we taking 25? Why are we not taking 150 here? Is that clear? Or any confusion?
I think it's clear.
Clear. Okay, very good. So let's carry on. So now you know again the corresponding production for unit 1, unit 2, and unit 3. So following this formula, okay, following this formula, now it will be P1, 14 because my I is 14 here. So it would be P1, 14. So accordingly, you can calculate this. Remember, now you have to add unit number 1 here in the formula. So the no load cost for unit number 1 will we have to take, and the associated incremental cost will be multiplied by 25, and you continue in the same manner. So please try it, and hopefully you will be able to come up with this value written here. State transition. Now you see we have a transition from 12 to 14. So how I have put these combinations here in bracket. So you can see L, which was the previous condition, which is 0, 1, 1, 0. Now I'm switching from this L to I, which is, what is I? I is 1, 1, 1, 0. So to have a transition from state 12 to state 14, I have to start a unit, which is unit number 1. I have to start up a unit, which is unit. So you can see that digit transition from 0 to 1. Okay, the remaining 1, 1 remains same. Unit 2 is still on. Unit 3 is still on. But unit 1, it was off initially, but now I'm deciding to turn it on. So because there is some associated startup cost with unit number 1, I have to take that cost here for this transition. So let's go and check back what is basically, or what is actually the startup cost. It is in slide 31. So with unit number 1, I have to repeat one thing, that in this case one, we are considering that all the startup costs are cold start cost. Okay, so we are not considering the hot start cost, but we are only considering the cold start cost. Okay, so if we are thinking about any starting up of any units, so we will simply take this value from this column. Okay, we don't think anything about this in case number 1. Whereas any unit, if we have to shut down, then in this example, they are assuming that shutdown cost is negligible. Okay, so unit shutdown cost is negligible. Remember this. Startup cost would be the associated cold start cost, and the shutdown cost will be the associated, shutdown cost will be assumed to be 0. So you see, if I try to turn on unit number 1, then I have to pay additionally $350. Okay. So this is the state transition cost for having a transition from 12 to 14 here in this column, in this row. Okay, so we have $350. Again, this column is 0 because we don't have any information about demand in the previous hour, so this is 0. So what would be this value? This value is simply this value, 9493 plus 350, which will give you 9843. Done. Then we go to the next feasible state transition. So the next decision whether we go from 12 to 15. Okay. So 12 to 15 means what? What is 15? Let's go in the capacity ordering table. 12 to 15 means, you see, all the units are on. Okay, all the units are running. So how do you decide among this? Anyone can explain this thing now? Demand is same. Demand is 450 megawatt. So how you fill up these 4 entries there for the first row of this row?
Sir, you run unit 4 at its minimum.
Yeah, unit 4 and unit 3 should be at minimum, and unit 2 the remaining portion. And first you of course take the 300. Okay, so basically you first start from the topmost unit, then you basically jump across to the lowest priority unit. Okay, and you fill up the minimum, and then you see, okay, the remaining is possible from the in between unit. Okay, the second priority unit. So this is how you do it. Same way. just you have the number 4 unit available, so you just fill up with the minimum value. This is how you do it, okay, in this example. So then you can calculate this cost, okay, simply use this formula. Now it will be P cost 1 comma 15, because 15 is your value of I here, 15. So you can calculate this. Now the transition cost, it was 0110. Now it has become 1111. So let's go and check what are the associated startup costs. Slide number 31. So you see unit 4 has no startup cost, okay? Unit 4 has no startup cost. So it is 0 for unit 4. But also we have to start unit number 1, you see? From this 12, combination of this 12, which was 0110, I have to turn on 2 units, unit 1 and unit 4. So unit 4 has no startup cost, so that is 0. But unit 1 has some startup cost, that is 350, same as this. So I just write it down here, okay? So then I just add this value and this value to get this value. Okay. Clear? Okay, we are still in our number 1. We have 8 hours to go. I mean, yeah.
I missed something. Why is this still 350?
Okay, this is 350. Okay, let's start from this combination again. It depends on this. Okay, so we are currently at 12. Okay, this is 12. Initial condition is 12. So it is 0110. We are going towards 15. My I value is 15 here. So this is the I combination 1111. So all the units are turned on. So then what we did, we checked the startup cost for unit 1 and unit 4. From this second row, we know that unit 1 has $350 associated startup cost. Okay, so only information missing here is what about unit 4. So let's go to slide 31. So you see unit 4 has no startup cost. Okay, it is a quick start unit. So that means my total cost is 350. Still it is 350. Okay, clear?
So if it is like any number, we add it, right?
Yeah, if it is non-zero value, simply you add with 350. Let's say it is 100, so it would be 450 in that case. Okay. Okay. So this is how you calculate this value. Simply you add this 350 and this 9861 to get this one. So as I said, our choice is the least cost option. So what is the least cost? I simply check this column and I have colored it in red. So the least cost option is that from the initial state of 12, in the first hour, I also stay at the same state. So this will give me the minimum cost option or minimum cost strategy. Okay, so I choose it. So the progress is, so at the last line of the slide says progress. Progress means what are the states I'm going through? Okay, how am I progressing for solving the unit commitment problem throughout the hour? Okay, throughout the hours. I have 8-hour problem. So in hour number 1, I have moved to 12. Okay, whereas initially I was also at 12. In hour number 1, I am staying at the same state. Now I talked about something about N. Okay, how many states we are going to save, how many states we are going to keep in our record. So in this example, we are keeping the 2 least cost strategies. Okay, we are keeping note of the 2 least cost strategies. So N is basically equals to 2. Okay, so what are the 2 least cost strategy? I can check this column. So it is 12. Okay, I is 12 and here I is 14. So 12 and 14, these are my 2 least cost strategies. So my N value is here 12 and 14. How will it affect the calculation? We'll see. Okay, I mean how this helps. What is the significance of choosing N? How will this help? That will be clear in the next slide, inshallah. So this is our number 2. Okay, our 2, the demand is read from the data. It is 530 megawatts. Now you see this N value is now basically changed its name to L. Okay, so that N from the previous hour, in the current hour, it is our L value. Okay, this is how it basically helps in calculation. So the n is basically L here in the current hour. And what are the feasible states? What are the X values? Again, I have to check among the 4 allowable states. Remember, we had 4 allowable states. There was also 5. State number 5 was also there in the allowable states. So you see the demand is increased. Okay, it was 450. Now it is 530. So of course, unit 5 cannot be feasible because unit 5, even it failed to satisfy 450 megawatt. So it has some less capacity generation. You can check it from slide 39. State 5 can only provide 300 megawatts. So can state 12 provide 530? Yes, it can provide. It is 550 maximum. So still my feasible states are 12, 14, and 15. Clear? This is how we are going to choose the feasible states. So it is still 12, 14, and 15. And again, it is not exactly the same as the allowable states. Why? State 5 misses out because due to the capacity problem, capacity limitation. So now L, we in place of L, we have 2 states. Okay, we have the saved states are 12 and 14. So L would be 12 and 14, 12 and 14, 12 and 14 like this. And the feasible states are I, which are 15, 14, and 12. Okay, so increased amount of computation will be required, but now you know how to calculate this, right? So you can simply go through this process. I can go through one or two, but I mean, it is the same process. Okay, it's the same process. So let's go through some of this. Okay, let's check. Let's say if I choose from 12 to 12 again. Okay, 12. If I still want to stay at 12 because 12 is one of my feasible states, so I can choose 12. I can choose to stay at 12. So 12 to 12. So if I am in 12 to 12, okay, and if I'm trying to go from 14 to 12, what will happen? So what was the cost associated in 12? Now we have this information basically here. This will help us to fill up these gaps. You see 12 here. It was, if I'm just a minute, I have called, just a minute, okay, just a minute. Assalamu alaikum. Hello. Hello, I class হচ্ছে বলো। মনে পড়াই দিমু ক্লাসের মধ্যে আবার আইবো। আচ্ছা ঠিক আছে, পাঠাই দিচ্ছি। ওকে, হ্যাঁ বলো। হ্যাঁ ঠিক আছে, ভালো করছো কইলা। ঠিক আছে, ওকে। হ্যালো, আসসালাম। হ্যাঁ, আপনি একটু আসেন তো, ওই রামপুরে যেতে হবে। আসেন, ঠিক আছে। Okay, I'm back. Sorry for the delay. Yeah. So let's go through this. We can choose either from 12 to 15 or 14 to 15 like this. Okay. So if I'm trying to go from 12 to 15 here, okay, let's say from 12 to 12 here, okay, I have simply written one of these entries, but you can simply fill this up. Okay, you can simply fill up 15 here. Okay, same thing here. You can simply fill up 14 here, and you can also simply fill this with 12 here. Okay, so that means 12 to 12. So if it is from 12 to 12, okay, 12 to 12. What is the state transition cost? There is no state transition cost, okay, because we are from 12 to 12, okay. So, and what was the associated cost at 12? The associated cost at 12 was, for if I was in 12, okay, you see, if I was in 12, the associated cost was the minimum 9208. So I will simply take that. I'll simply take that and I will take it to the minimum cost strategy here. F cost at the previous interval k minus 1, that is the first interval, because remember now I have the value of k equals to 2. So this F cost value will be taken from the previous interval, previous hour. And when we were at L was 12. So when I was at 12, what was the cost? It was 9208. So this value, okay, when I was at 12, this was my F cost. So the F cost Ki in our number 1 simply will become F cost K minus 1L, clear? Because I'm in the next K value. So that value will be simply taken and copied there in this column. So this is the associated cost at 9208. What would happen if I chose 14 instead? Remember, my saved state is 14 also, not only 12, not only the minimum cost strategy. I'm also saving another state because my value of n is 2. Okay. So what would happen if I chose, instead of 12, I chose 14? Then what would happen in this hour 2? Okay, if I now choose to transit from state 14 to state 12 to satisfy the demand. Okay, so if I'm in state 12, if I'm jumping from 14 to 12, then what would I do? In 12, what do I have? My combination is 0, 1, 1, 0. This combination. You see this combination. The combination of I here, remember this is column I. So this is your I here. So the last entry here is the I. So 0, 1, 1, 0. 0, 1, 1, 0 will simply, you will turn on 2 units. Okay. You will keep 2 units on the topmost priority unit, the two of the topmost priority units. So your demand is 530. So you fill up whatever is available from your most preferred unit, that is 300, and the remaining you can fill up from the next unit, which is unit number 2. What is the transition cost? Okay, what is the production cost here? You can calculate it. This is shown in the previous slide. Okay, P cost. Okay, this is P cost. You can calculate. There will be no load cost and the incremental cost multiplied by the corresponding generation or production here. What is the transition cost? Transition here means I'm having a transition from state 14 to state 12. So that is to say I have to turn off unit number 1, right? I have to turn off this unit. You see, it was 1 here. Now it is 0 here. The remaining are same. The 0 here. So there is a transition of unit number 1 from on to off. But as we say, that means we are shutting down unit number 1. But as we said, there is no shutdown cost. So this transition will not create any additional cost. Clear? Okay. So this is the P cost. And what was the F cost at state 14? That is saved, and that is taken from here from slide 40. This is associated with state 14. Okay, you see 14, 9843, 9843. So you take 9843. So then I add, so I have to fill up this now. Then I add this value, okay, this P cost with this F cost, and this P cost with this F cost. So of course, if I add this one with this one, there will be some value, but that is of course will be higher than this. You see, it is this value remaining same. If I'm comparing between this value and this value, this is lower. So I'm simply writing this one. You can also fill up this one, this entry, but this will be of course higher than this. So among these two, this is the minimum. Okay, so I am only, because my choice will be towards minimum, my tendency is to choose the minimum among the options. So I simply write down the minimum among the two options here, from 12 to 12 and 12 to 14 to 12. Okay, so I'm only having the minimum among these two. Same thing I will do for others. So I have two previously saved states, 12 and 14. Now I value is this second feasible state, which is 14. So now you can cross check these things. Okay, I'm not going to go through all these calculations. Just I have given you the basics, how you are going to fill this up. Okay, how you are going to calculate this, and I have only chosen the minimum one. Actually, what you can do, you can also fill this up. Okay, this plus this plus this, you can write it down and we can compare among these two, and you can keep the minimum. Okay, so do I need to go through all the details of this? I don't think so, because these are just the repetition of the one which I have said. So among these three, again, I have put the red colored one as the minimum.
Sir,
Yeah,
I have a question.
yeah, sure.
Previously you said that we have chosen L equal to 1214.
Yeah,
Okay.
we have chosen the two least cost strategy, 12 and 14, because
Yeah.
these were giving me the two least among the three available options. These two were the
So
least cost options. Yeah.
if, for example, we had 15 having a lower cost than 14, it means that it will be 12 and 15.
Oh, it's not clear. Can you repeat, please?
I mean, for example, in case, for example, we have step 15 having a lower cost than step 14.
Yeah, of
It
course.
means that we will have
If
12,
yeah,
15.
if state 15 is having lower cost than state 14, and
Yeah.
my choice is go for two least cost strategies only, then I would have chosen 12 and 15 instead of
Okay.
12 and 14.
Okay.
And in that case, these entries here for L would have been 12 and 15, 12 and 15, 12 and 15. Okay.
Okay.
Thank you. So what I was saying, then again, I see that, well, my transition from 12 to 12 and 12 to 14, these are the two least transition cost. Okay, 12 to 14, you see, you can also write 14 here. So this row belongs to transition from 12 to 14, and this row, the last row, belongs to transition from 12 to 12. So again, I save the two least cost strategy. Okay, that is 14 and 12. Remember, I choose the I values for saving. Also here, I choose the I values, okay, not the L values. I chose the I values, 14 and 12. So 12 and 14 here. Similarly, the I value here, 12 and 14, these are the two least cost strategy. And my decision is to progress with the least among them. That is still 12. So it is 12 in hour 1, 12 in hour 2 also. In hour 3, the demand has further increased, and it is such that that state 12 is unable to satisfy the demand anymore, because remember, state 12 can only provide 550 here. So state 14 and 15 are the only two feasible states now in our number 3. Previously saved states are 12 and 14. And again, my feasible states are limited. 12 has gone out of the set. It is not a member of the set. So again, due to capacity, it is limited. So again, now you choose the previous saved state is 12 and 14. 12 and 14, they belong to L. And my current feasible states belong to I, which are the elements within X. So it is 14 and 15. So similarly, you calculate it, you fill up the blanks, okay, and you simply calculate the remaining values. So how do you fill these up? Simply you take, remember, you see the values are same. Okay, 19856, 19856. They belong to 12 from the previous slide, this slide, 19856. And associated with 14, we have 20491. So you see 20491. Wherever we have L14, it is 20491. L is 14, it is 20491. So, and the remaining, you know how to calculate the transition cost now, how to calculate the production cost now, and so on, right? So in this way, we can proceed. Okay. And here also we see that, well, because 12 is no more a feasible state, so it's very clear that we can't stay at 12. Our state has to have some transition. So in this case, we see that transition from 12 to 14 in our number 3 gives us the least cost strategy. So we progress as 12 in our 1, 12 in our 2, and in our 3 we have 14. So we are going to save 2 strategies, but actually we only have 2 strategies to save. So we simply choose 14 and 15. Okay, we simply choose 15 and 14 because these are the only 2 available states, and I'm going to save both of them. So for the next hour, this would be my L value. Okay, this N will be simply converted as L, translated as L in the next hour.
Sir.
Yeah.
So why are we choosing to save 2 states? Once
Yeah.
we determine which is the optimal one, then why are we taking another, considering another state?
Yeah, that's a very interesting question, but it is difficult to answer. I mean, at this point, okay. Look, what would happen if you do not choose sufficient states? Okay, if you do not choose sufficient states, then you might reach a position through your progress. Remember, we are progressing like this, okay? If you do not have sufficient states, let's say, very important question here. Let's say, okay, now at this point I can answer it. Okay, I have got the answer here. It is ready. So if you have asked it before, then it would have been difficult for me, but now it is ready here. Look, if I had saved only 12, okay, this is the optimal strategy, right? 12 is the optimal strategy. So let's say I save only 12 here in our number 1. I save only 12 in our number 1 because it is still it's still our minimum cost strategy. What would happen at our number 3? Our number 3, you do not have state 12. You see, your feasible state is it is not actually available here. You don't have the feasible state here. So you would be in such a position that will be in a position that you can't progress any further if you limit the choice here. If you limit your choice here, you get my point. At some point of your progress, probably you would reach in such a situation that if you only save the most optimal, then actually you are losing your strategies. You will see that at some point you have to shift from, let's say from 12. Okay, although 12 is your most optimum solution till at this point up to hour 2, but hour 3 you can't stay at 12. You have to shift from 12. Okay, so now in this example, till now that is not clear. What I want to say at this point, that is not still clear, because the calculation is such that it is related with 12 most of the time. Okay, it is related with state 12. But let's say at some point of time you come up with a different least cost strategy. Here you see it is still 12. Okay, here it is 12. But if some case you come up with some strategy where maybe 15 or 14 would be your least cost strategy, but you did not save it here. Remember, this L value, from where it is coming? It is coming basically from previously saved state, right? Are you getting the point?
Yes, sir. I think I'm catching on.
The L value is coming from the previously saved state. If you did not save all these, let's say you did not save, I'm saving what? I'm saving 14. So let's say you did not save this one, okay? Because you only saved 12. So you have only one choice, 12 to 12. Then you did not save this 14. So you have only one choice, 12 to 14, right? You did not save this choice. This is not available. So you only chose 12 to 15. So there might be case that although it is not clear from here it is the transition from 12 to 15 is minimum, right? But there might be some cases where 14 to 15 instead would give you minimum cost instead of 12 to 15. So if you did not save 14, then probably you might not go for the most optimum solution. If you did not have this information here, if you did not save this cost, this is what I mean. If you did not save this cost from the previous state, the 14 is not saved, then probably, let's say, if instead of this value comes up here, okay, it is 20859. Let's say here you have 1800 something. Let's say, just for an example, what would happen? If you did not choose 14 as this previously saved state, you are missing with this transition, right? So if you did not have this, but that would yield 1820, as you did not save it, you do not have this information available. Only you have information that 19,856 is your minimum cost. Why? Because you did not save it, right? But now because you saved it, and probably by calculation you find that, okay, it is 18,200. So you could choose, okay, from here I will transit from 14 to 15. I am not transiting from 12 to 15. Okay.
Yes,
So
sir. I think I got it.
yeah,
But
probably,
this gives rise to another question in my head. That is, let's
okay,
say I have.
just a minute. I have to attend my doorbell. Okay, just a minute.
Okay, okay.
Doorbell. Yeah, please.
Okay, sir. Let's say in this scenario, we have 4 possible states, right? 5, 12, 14, and 15. Those are the
Here.
no,
Four
no, no.
possible.
I'm not talking about a particular time.
Okay. Yeah, we have 4.
So out of those 4, we're choosing to save two states, right? In each step.
Yeah.
So
Why
suppose
not 4? Why not 4?
why not more than 2, or what determines that 2 is the right number?
Yeah, no, 2 is not the right number. You can have some trial and error policy. You can't generalize this. This is the problem. You are actually going for some trade-off.
Okay.
I stated this at the beginning of the lecture when I mentioned about this specific issue. So I said, if you are, look, if, as I'm saving only 2, let's see how the calculation is increasing with time by hour. Okay, if I save all, so what will be the size of this table? Okay, let's say if the unit number is 100 of units you have, how much data you have to save, how much combinations you have to calculate, that would be enormous. Okay, the exact calculated value is provided in the book. I have not included in this lecture. It is millions of data you have to calculate, you have to store basically. Okay, so that's why you, at one end, at one extreme, you can't go for 2 less an option, like you can't only choose 1. Okay, in that case you are losing some information. You can't go for saving all the possible strategies. That would be computational burden on your system. So there is always some trial and error type thing. Okay, you have to play with this for each problem, and then probably you will come up with some solution which is best suited for a particular problem. But for this one, as it is taken from the book, probably they did it for us, and I'm just taking that value here, 2 least cost strategy. Okay.
Okay, sir.
But to be assured about this specific value, what should be the value of n? This is, I mean, you can have probably research on this. How many strategies should I save? Okay, should I stick with 2 only? Should I go for 5 or 4? Should I take only 1? Okay, so this is, I mean, this is not one line answer. This is trade-off. Okay, I hope you get the answer somewhat to some extent. Okay, so we were in which hour? We finished hour 3, right? Okay, so then at hour number 3, we found that, okay, we have to switch from state 12 because state 12 is no more a feasible state. So among state 14 and 15, these 2 feasible states, my choice is with the minimum of these 2 options, which is state 14. So the transition progresses as this, 12, 12, and 14, and I am saving these 2 available strategies, 14 and 15. Okay, so then we continue. Now the demand has decreased. So again, we have 12, state number 12 included in the feasible state. We continue the calculation. And here it is again seen, it is seen that the state transition from 14 to 12 is the least cost strategy. So, and the next least cost is 14 to 14. So again, I save 12 and 14. And if I continue like this, and the load is actually reducing further. So if I go on with state 5, state 6, sorry, hour 5, hour 6, hour 7, I'm not going through the detail. Please go through the detail, okay? Please go through the detail of this calculation. So now at hour number 7, we see that the load is, okay, starting from hour number 6, the state 5 is also included as one of the feasible states because the demand is such that state 5 can also satisfy this demand. That's why it is included as a part of the feasible state. So now you have in set I, you have all the 4 combinations, 5, 12, 14, and 15. So then you calculate, and the least cost strategies are found to be transition from 12 to 5, and the next least cost is transition from 12 to 12. So I save these 2 strategies, 5 and 12, and the progress moves away from 12, it goes to 5. From round number 7, it is still 5. Round number 8, the demand again increases. So accordingly, we find that our strategy also shifts to state number 12. So this is my 8-hour plan or unit commitment plan of turning on the units or turning off the units, and the associated least cost is this, okay, 73437. This was the case with, this was done for case number 1. Now, what is the basic difference between case 1 and case 2? There's a very subtle difference because we have some different assumptions there. So case 1 dealt with pure priority ordering scheme, but case 2 gives us another option of solving the problem. This is enumeration scheme, where we do not look for any specific priority scheme. Rather, we can choose from any of the states. Okay, so there is no priority ordering. So we can choose from any of the states based on the fact that that state is able to satisfy the demand. Okay, but no priority scheme is done. So to start with, we are not only restricting ourselves to state 5, 12, 14, and 15. Okay, we are not restricting ourselves based on any priority. Okay, this is the explanation of the first two lines, first 2 points there. And the minimum uptime and downtime are still ignored, and still hot start cost is ignored. So we are still living with the cold start cost. So now, what are the feasible states? I will simply go through the differences. Okay, I will not go through very specific detail of this calculation, because the calculation process is exactly same. Just the difference comes here. Okay, our initial condition was still 12. Load is still at our number 450. This is the difference. So the feasible states, now you see I have included 13. In the previous case, case number 1, 13 was not part of the feasible state, or even it was not part of the allowable state because of priority ordering. But now 13 is one of the feasible states. So you have to choose the transition from 12 to 12, 13, 14, and 15. So accordingly, you can calculate. And here is still the transition from 12 to 12 is my least cost strategy. The next least cost is 12 to 13. So you see 13 comes into play. Previously 13 was not chosen due to priority ordering. So instead of 14, we chose 13. But still n, we are as well as the value of n, we are choosing 2, the 2 least cost strategy. So the next hour, 12, 13, 14, 15, demand has increased. So still we are with 12, 13, 14, and 15. The remaining states are not part of the feasible states because of capacity limitation. So again, you calculate the transition cost, you calculate the production cost, and you take this value of this column from the previous slide, and you calculate the minimum among the options, and the least cost is your progress. So still it is 12 to 12, and you still save 12 and 13 because these are the 2 least cost strategies. So in this way you progress. So there is no other differences, actually, no other differences. So if you complete this, then you will find that at the end of our number 8, your progress looks like this. What is the difference between this one and the last one? The difference is only at this point. Okay, it was 14 there. If I just check back, if I just copy that, let me try copy that one. This one, yeah. So if I just copy it, okay, do you hear me?
Yes, sir.
Okay, the connection was lost for a very short duration. Okay, what I want to say, if I just try to compare that one, okay, this is case number 1. Sorry, this is case number 1. I copied it from here. So I'm looking for case 2.
So we cannot see the slide.
Okay, okay. Let me share it. Can you see now? Do you see now?
Yes.
Okay. So if I just compare it,
Yes, sir.
so you see this was the lower one. This one is from case 1. So you see all the okay. This is sorry. This is not the slide. I have to go up to our number 8. So yeah, this is it. So you see, we start with 12 and 12. So here in case 1, it is 12 and 12. Then we shift, in case 2, we shift to 13. But here we shift to 14. Okay. So this is the only change. The remaining things are remaining same. Remaining strategy is exactly same. What is the cost here? The cost in case, oh, the cost is not calculated finally because it was too, it was too much burden on me. So I didn't finally calculated it. So it is left to you, or you can check the value from the book. Okay, I have just shown the progress and the corresponding feasible state. You see the feasible state, the number of feasible state here, how much? 1, 2, 3, 4, 5, more than probably 10. So all these, I can't put them in one slide actually. That's why I did not put it in the slides. And here also in our number 7, our number 8, it is less, but our number 7, it is again huge number. So you can't actually put them in one slide in an elaborate manner. So I've just put the progress here. You know how to progress with the decisions, but the exact cost up to state up to hour 5, it is 51,442. Final cost you can obtain, it is available in the book, and you can compare, okay, among these two strategies, okay, in case 1, in case 2, what is the difference in cost. So the time is almost done, so I would like to stop here. Any question? Any question? Please put your IDs in the chat box before you leave. Please type your IDs. Any question?
Yes, sir. Can you please go to case 1, hour 3?
Okay, sure. Case 1, hour 3. Yeah.
Okay. Yeah, I would like to ask, why have you highlight case 2 in red, like to show that it is a
No, red
current
is,
safe state?
yeah, it is chosen. Red means it is the minimum among these possible strategies.
Yeah,
Just-
it is minimum, but I think it should not be chosen as it is not part of the feasible state.
Which one are you talking about?
The state 12.
No, state 12, these information is coming from the previous hour. In the previous hour, 12 was feasible. Actually, 12 was the chosen state. In this hour, you see, this I relates to this current hour number 3. Here we are not taking 12. So we are not taking any transition from 12 to 12, 14 to 12, and so on. Okay, 12 will not be present here in this column. But of course, 12 is available in previous hour. Okay.
Okay, sir.
Okay. Anything else? Have you put your attendance? Then you may leave if you don't have any other queries. And we will continue this slide. We have very small portion left. And then after we complete this slide, we will shift to a new topic, inshallah, the next class. How was the quiz? Was it good? Everyone is busy with giving their attendance.
Yeah, it was
Yes,
fine.
Isaac, it was fine, right? Okay.
Yeah, but the timing, sir.
Oh, timing was also fine, I think. Half an hour is more than enough.
But I faced some problems, so I couldn't submit on time. I submit after 3 minutes, I think.
Okay, I will check. I will check. If you have completed everything, then I will, inshallah, consider your issue.
Thank you.
Okay, welcome. So I'm stopping the recording, stopping the meeting. Okay, let me stop the sharing first. Stop share.